Section 9.4, Working with Taylor series. This section, we are going to evaluate limits, differentiate power series, integrate power series, and represent real numbers using the Taylor series. The table that you see is a list of the functions that can be represented by the Taylor series about x equals 0. Limits by Taylor series. Evaluate the following limits using Taylor series. In part A, limit as x approaches 0 of the function x squared plus 2 times cosine x minus 2 divided by 3 times x to the fourth. This is the limit of the quotient indeterminate form. So we can be evaluating this one by using the L'Hopital as we learned in count 1. But this time, we are going to evaluate the limit using the Taylor series. For the expression of the numerator, we have the cosine term. We are going to rewrite the cosine term into the power series or the Taylor series at x equals 0 as cosine x is 1 minus x to the second over 2 factorial plus x to the fourth over 4 factorial minus x to the 6 over 6 factorial and so forth. I recommend you to write up to at least 4 terms. Next, we are going to substitute the cosine into the expression. Before we substitute, we write it in the manageable form as the quotient is the same as multiplied by the reciprocal. So we rewrite it as 1 over 3 times x to the fourth multiplied by the expression of the numerator. And at the same time, I'm going to rewrite x squared minus 2 together and then added by 2 multiplied by the cosine x, which is in the Taylor series form as 1 minus x squared over 2 factorial plus x to the fourth over 4 factorial minus x to the 6 over 6 factorial and so forth. Now, we're going to simplify the quantity in the parentheses. We have x squared minus 2. We simplify by multiplying 2 to our terms for the power series. Then we get 2 minus 2 multiplied by x squared over 2 factorial plus 2 multiplied by x to the fourth over 4 factorial minus 2 times x to the 6 over 6 factorial and so forth. And simplify the terms. 2 and 2 factorial can be reduced. 2 and minus 2 cancel. X squared and minus x squared will be cancelled. Now the limit is in the form of 1 over 3x to the fourth multiplied by the first term would be starting from 2x to the fourth divided by 4 factorial. 2 times x to the fourth divided by 4 factorial minus 2 times x to the 6 over 6 factorial plus and so forth. And then since this one, as you divide all by 3x to the fourth, x to the fourth of the denominator will be reduced with the power of each term of the numerator. So this one becomes x to the second, and so forth. Now, the limit is simplified further to be 1 over 3 multiplied by 2 divided by 4 factorial minus 2 times x to the second over 6 factorial plus and so forth. The later term gonna have the power of the x in some form. So only the first term, that is just real number, we take the limit as x approaches 0. The later terms involving the x will approach 0. Now the limit of this function becomes 1 over 3 multiplied by 2 over 4 factorial, which gives us 1 over 36. Next example, the limit of the quantity e to the power x minus e to the power negative x divided by x. The e to the power x with the Taylor series representation is 1 plus x plus x squared over 2 factorial plus x to the third over 3 factorial plus x to the fourth over 4 factorial and so forth, where e to the negative x is 1 minus x plus x squared over 2 factorial minus x to the third over 3 factorial plus x to the fourth over 4 factorial and so forth. As we replace x by negative x of the e to the power x Taylor series form, then the e to the negative x becomes alternating series. But the even power will remain the same positive sign. Now we replace them into the expression of the limit. So limit as x approaches 0, we write it as 1 over x multiplied by e to the power x minus e to the negative x. So limit x approaches 0, 1 over x. For the e to the x, all terms are positive. Where e to the negative x is alternating series. This is minus I, sorry. Now, we're going to subtract these two groups. The term that have the same sign will be cancelled, or the term with the even power will be cancelled. Then we get the simplified form as 1 over x multiplied by twice of the odd power term, and the sign of them now becomes positive. And next, divide all by x. We have 2 multiplied by 1 plus x to the second over 3 factorial plus x to the fourth over 4 factorial, 5 factorial plus x to the 6 over 7 factorial and so forth. As we take the limit as x approaches 0, the terms involving the power of the x will go to 0. The answer of this is 2. This example, we find the limit as x approaches 2 for the quantity x minus 2 divided by the natural log of x minus 1. The Taylor series can be used for the natural log term. From the table, the natural log that we have is natural log of 1 plus x equals x minus x squared divided by 2 plus x to the third divided by 3 minus x to the fourth divided by 4 and so forth. But the form that we have, which is a natural log of the quantity x minus 1, is similar but not easy to replace it right away as some function like e to the x, e to the negative x, and so forth. Now we are going to adjust the argument of the natural log to fit the pattern of the natural log of 1 plus the quantity x. So for the natural log of x minus 1, we're going to transform into the natural log of 1 plus some quantity, and then we can replace the quantity at the x position, and so forth. That means from the x minus 1, if we write it as 1 plus some quantity, what would be that quantity? That quantity would be x minus 2. So we can rewrite it as the natural log of x minus 1 is the same as natural log of 1 plus the quantity of x minus 2. And with the quantity x minus 2, we can use the pattern of the natural log of 1 plus x, as the quantity x now is going to be the quantity x minus 2. Then we get x minus 2 power 1 minus x minus 2 to the second over 2 plus the quantity x minus 2 to the third power over 3 minus quantity x minus 2 to the fourth over 4 and so forth. And then back to the main part of the problem. We have the limit as x approaches to the quotient x minus 2 divided by the natural log of x minus 1, which is the series x minus 2 minus x minus 2 squared over 2 plus x minus 2 to the third over 3 minus x minus 2 to the fourth over 4 and so forth. We notice the same factor like x minus 2 appear everywhere. We're going to treat them by dividing both numerator and denominator by x minus 2. So divide both numerator and denominator by x minus 2 to obtain the limit as x approaches 2 of the 1 divided by 1 minus the next term, the power of x minus 2 is reduced to be 1 and then divided by 2, and similar to the rest of them. Take the limit as x approaches 2. The x minus 2 quantity approaching 0, approaching 0, approaching 0. Therefore, the limit value for this problem approaches the value 1.